So I'm willing to bet the one thing you're sitting here thinking right now is, I have not done enough calculus in this class. And you'd be right, because this is Cal-based physics. We should be doing calculus. So just like the spring problem where things aren't just necessarily like perfectly beautiful. So let's say you've got this parabolic path with the da-ba-da-da-da-da-da-da-da. Okay, so as a math person, I don't really care what's happening. It's just, oh, look, it's a math problem. For anyone who's doing this and cares about real life applications, you'd be like, I don't remember, and I can't help you there. Right now, I just want to make sure you remember how to do some math because it's an important math skill to remember how to have. All right, so I'm going to glean out all the necessary parts of this problem. So I have a curve, 1/2 x squared, where it goes from 0, 0 to 2, 2. And I have a force, and if I take out the units, it's going to be 5y I hat plus 10x j hat. Okay, so given that and that, I want to find the work done by whatever that is along that path. So that force along that path, what kind of work does that force do? Okay, so this is where we just need to remember how to do some calculus. All right, so the definition of work is F dot dr. Okay, so you're like, what's dr? I forgot. Well, dr is technically dx, dy, dz. Okay, so like all the little itty bitties and all the little itty bitty directions. In our case, because we're assuming a non-rotating reference frame. So I'm just letting you know things can get harder. So if you're like, well, why did you be earlier, blah, 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 blah. Okay, well, because in general, things can change. But right now, we're assuming a nice, pretty, boring reference frame. Okay, so let me just look at the f.dr part. So if I have 5y, 10x, and 0, and I'm dotting it with dx, dy, dz, I'll end up with 5y dx plus 10x dy plus 0 dz. Okay, so all that goes in an integral, and since I know I can break integrals apart at plus signs, and I'm just going to go ahead and do that. So I can pull my work out as being the integral of 5y dx plus the integral of 10x dy. Here's the problem. I can't integrate y with respect to x and x with respect to y just out of the blue. I need to write the entire thing, or at least every entire individual integral in terms of either x or in terms of y. The first one actually isn't too bad because I know that y is equal to 1/2 x. So I can actually just make that directly. So I'm going to go 5, and then where it says y, I'm just going to plug in 1/2 x squared. So that's just a direct plug-in. I'm going to leave this one for a minute. Okay, we're going to come back. But let's get some confidence while we can. So now we got to figure out what our limits on our integral are. So, so we've got x. So where does x go? So from our picture, it went from 0, 0 to 2, 2. So actually this is really easy. It just goes from 0 to 2. Whether we're on x or y, the limits are going from 0 to 2. So what I've really got here is the integral from 0 to 2 of x squared dx, which is just going to be 5 over 6 x cubed evaluated from 2 to 0, and again, plus heart. So that's 5 times 8 over 6, and this is the part I always get wrong. Divided by 2 is 3. So 20/3 plus whatever this heart thing is. Okay, so that's part of the answer. Part of the answer. Now, let's try this again. Let's look at this other part. I can't just plug in y. I mean, I can. So let me do it two different ways. and you do whichever way makes you happiest. Okay? So I'm going to do 10x dy. Remember I had y equals 1/2 x squared. So I had y equals 1/2 x squared. So if I solve for x, I've got 2y equals x squared, so x is equal to, now plus or minus the square root of 2y, I happen to know from the picture that I'm only using the positive root because I'm in the positive quadrant 1. So I actually can stick with just that. So here I can go 10x is actually 10 times the square root of 2y dy, and y goes from, again, 0 to 2. So that's 10 square root of 2 times the integral 0 to 2, and instead of writing it square root of y, I'm going to write it as y to the 1/2, because then, how can I do it? I can do y to the 3/2, so to the 3/2 evaluated from 2 to 0. So whatever that ends up being, 20 square root of 2 over 3, and then y to the 2 cubed 8 square root of 8. Okay, I'm going to try this again. I'm going to do too many steps at once. So this is y to the 3/2. So this is 2 to the 3/2. And 2 to the 3/2 is 2 to the 1 times 2 to the 1/2. So that's 2 times the square root of 2. Okay, I can do this. I'm really good at math, I swear. I'm just putting this off to the side so that we don't forget what we're doing. So this is times 2 square root of 2. So what is that? 40 times 2 over 3 is 80 over 3. Okay, so then heart is 80 over 3 equals 100 over 3. Okay, so in theory, that should be the answer. Let's show you another way to do it. And you might not like this, and that's okay. But in case you didn't like that one, you might like this one better. All right, so again, we have this 10x dy. Now, instead of changing the x, we could change the dy. So since we have that y is equal to 1/2 x squared, this is weird sounding, but how do I want to say this? Okay, I'm just going to say take the derivative of both sides, but I'm not going to tell you what we're taking the derivative of. We're kind of taking the derivative of it with respect to the universe. Just d both sides. If I d both sides, I would say get dy. And then if I d the other side, if I take the derivative of the other side, I get x, but it's chain rule, so I get x dx. I feel like there's a better way to explain this, and my brain isn't functioning right now. But another way to write this is that dy is the same thing as x dx. So I have 10xy is 10x times x dx. And I think that's actually what your book does. So I have x squared dx going from 0 to 2. So I have 10/3 x cubed going from 2 to 0. So that's 10 times 8 is 80 over 3. And so I got the same answer, 80 over 3, both ways. It's just whichever way makes more sense to you from a math perspective, and you can get the right answer, do that. And in any case, the answer is 100 over 3. So something like that, 33. Okay, and then that's Newton's squared joules. Okay, and the units is generally going to be joules. Okay, so I think earlier when I was doing the video, I mentioned it as like foot times pounds, and that's what it is in foot pounds, and that's what it is in customary units, and in our units here for what do you call this thing? Scientific notation, it's joules is the unit of work, joules. So 10 over 3 joules. Okay, sort of. So there's some calculus for you. That ought to keep you busy for a minute.